Okay, these are the answers for the CCEA Fact File for A-Level Chemistry, Unit 4.7 Aldehydes and Ketones. So question 1. Which one of the following compounds produced a silver mirror when heated with Tollens reagent? Well, if you're getting a silver mirror with Tollens, then it must be an aldehyde. And looking at all of these, you can see here, these ones, A, B and D, all have oxygens attached to the middle carbon. So that can't be an aldehyde, it has to be C, where the carbonyl group is on the end. Number 2, an organic compound X gives an orange crystalline product with 2,4-dinitrophenylhydrazine, but does not give a precipitate on heating with failing solution. Which one of the following formula is that of X? So if you're getting something with 2,4-DNPH, but not with failings, then it must be a ketone. And it's like the opposite of the previous question. So here, here, and here, we've got the carbonyl groups at the end. D is actually an acid. That means it has to be C. Now, name the compound CH3CHO and state its functional group. Well, it's ethanol, and the functional group is the carbonyl group. Now, name and outline a mechanism for the reaction of the CH3CH2CHO with HCN. So that's propanol with the HCN. Oops. So, obviously, it's nucleophilic addition. That's the type of mechanism for all of these ones that we've looked at. And drawing it out here, we see we have the CH2CH3 group here and the carbonyl group here. Here's the CN minus, and you see that the direction of the arrows here and here, we've got delta plus and delta minus on the carbon and the oxygen there. What happens next is we have this, the O minus, and we have the CN attached to that carbon. The other two groups there are the same, and then we see the hydrogen ion here, the electrons are moving towards it. And finally then we've got our same groups that we started with an OH attached to the carbon and also the nitrile group. State and explain how a racemic mixture is formed in this reaction. Well, the CN minus attacks on either side of the carbonyl group, and the carbonyl group is planar, and that means that you get an equal mixture of both optical isomers. Number 4, some Scotch whiskies have the fragrance of cut grass. This smell is attributed to cis-hex-3-enal, which is an unsaturated aldehyde. Now, cis is the same as E. I doubt they would say cis in the exams now, but you never know. But C, I do refer to them as E and Z enantiomers rather than, or E and Z isomers rather than cis and trans. So you want both the high priority groups on the same side, and so you've got C2H5 on one side and CH2CHO on the other, and then just the two hydrogens there and the double bond in the middle. What would be observed if 6-hex-3-enal is warmed with failing solution? Well, the blue solution would develop a red precipitate. It would change colour to give you a red precipitate. Then write the equation for the reaction between cis-hex-3-enal and 2,4-dinitrophenylhydrazine and represent the structure of cis-3-hexenal as this. So it says there's no requirement to draw the full structure, which is quite useful. So there it is, and then this is your dinitrophenylhydrazine, and then you see here with this nitrogen the bond breaks and you end up with it joined to the carbon there, and you get your hydrazone. So 3 marks for that. It is worth definitely learning how to draw the structure for 2,4-dinitrophenylhydrazine. Thanks for